Imagine a world without drugstores. No plastic bottles filled with perfectly uniform pills. No lab coats, no clinical trials, no 2-day shipping for your headache medicine. That was the reality for centuries. Your pharmacy was your garden, the local woods, or the monastery down the road. The pharmacist was an herbalist, a village healer, or a monk who spent his days tending to plants. They dealt with everything we do. They had aches, fevers, anxiety, insomnia, and infections. But they faced them without germ theory, without an understanding of brain chemistry, and without a clue about cellular biology. They relied on knowledge passed down through generations. Knowledge built on trial, error, and careful observation. Much of it was likely superstition. Some of it was probably dangerous. But what if some of it was right? What if, hidden in those ancient texts and folk traditions are remedies that work for reasons we're only now beginning to understand? It's easy to dismiss medieval medicine as a dark age of leeches and questionable potions. And yet, modern science is starting to look back at that very same garden. It's putting these old plants under the microscope. And it's finding that our ancestors, in their own way, knew exactly what they were doing. Are we just rediscovering a wisdom we chose to forget? Number 17. Could a tree's skin really cure a fever? The willow tree loves water. You find it in damp places, along riverbanks, and in marshy fields. And in the medieval mind, this was a clue. The doctrine of signatures was a common belief. It held that God marked plants to show their purpose. A plant that thrived in damp, cold places must be good for damp, cold illnesses. Things like fever, agues, and the deep, aching pain of rheumatism. So, for centuries, people chewed on the bark of the willow tree. They made bitter teas from it to bring down fevers and soothe aching joints. It sounds like pure folklore, but this is one of the clearest lines we can draw from the medieval herb garden to the modern medicine cabinet. The connection is so direct, it's almost unbelievable. The active compound in willow bark is called salicin. When you ingest it, your body, specifically your liver, converts it into salicylic acid. This substance is a powerful anti-inflammatory and pain reliever. It reduces fever, swelling, and pain. It was the original plant-based painkiller. For a long time, that's where the story stayed. It worked, but it could be hard on the stomach. Then, in 1897, a chemist named Felix Hoffmann, working for the German company Bayer, found a way to modify salicylic acid. He created a more stable, less irritating version called acetylsalicylic acid. When Bayer marketed this new drug under a new name, they called it aspirin. It became one of the most widely used drugs in human history. And it all started with a bitter tea made from the skin of a riverside tree. Modern research confirms what medieval healers observed. A 2009 study in the journal Phytotherapy Research reviewed multiple clinical trials. It found that willow bark extract was effective in treating lower back pain, often comparable to conventional medications. The key difference is the delivery system. Aspirin is a single, isolated molecule. The willow bark is a complex cocktail of compounds. It contains salicin, yes, but also polyphenols and flavonoids. Scientists now believe these other compounds might work with the salicin. They may enhance its effects and even provide a protective buffer for the stomach, explaining why some people find the whole herb gentler than the synthesized drug. They were taking not just the active ingredient, but the entire synergistic package, just as nature made it. So they didn't know about salicin, they didn't know about prostaglandin inhibitors. They just knew that a tea from a tree that loves the damp could help with damp, aching pains. They were right for the wrong reasons, or maybe their reasons were just a different way of describing the same truth. But what don't we know? If they isolated one compound, salicin, to make aspirin, what other beneficial compounds did we leave behind in the bark? How do those other plant chemicals change how our bodies use the main ingredient? And how on earth did the very first person figure out that of all the parts of a willow tree, the bitter inner bark was the part that held the medicine? Number 16 was driving out demons, just an old way of saying treating depression. In the Middle Ages, melancholy was not a chemical imbalance, it was a spiritual affliction, a darkness of the soul. It was sometimes seen as an invasion by evil spirits or demons. To fight it, you needed something more than just medicine. You needed a plant with a holy reputation. And for that, they turned to St. John's wort. The plant, with its cheerful yellow flowers, was named for John the Baptist. It was said to bloom around his birthday in late June. If you held a leaf up to the light, you'd see tiny translucent dots like little punctures. Legend said these were the tears St. John wept when he was beheaded. Red pigments in the flowers would stain your fingers, a symbol of his blood. This plant was steeped in powerful symbolism. It was hung over doorways on St. John's Eve to ward off evil and protect the home. It wasn't just a plant, it was a shield. And they made it into teas and tinctures to drive the demons of sadness from the mind. They also used its oil, which is bright red, to heal wounds and nerve pain, calling it the blood of Christ. Fast forward to today, we no longer talk about demons, we talk about neurotransmitters. We talk about serotonin, dopamine, and norepinephrine, and St. John's wort, the demon chaser, is now one of the most studied herbal remedies for depression in the world. In some countries, like Germany, it has been prescribed by doctors more often than synthetic antidepressants for mild to moderate depression. The German Commission E, a highly respected scientific advisory board, has approved its use for this very purpose. The science is compelling. The plant contains active compounds, most notably hypericin and hyperforin. For a long time, scientists thought hypericin was the key. Now, most research points to hyperforin. It seems to work by preventing the reuptake of key neurotransmitters in the brain. This means there's more serotonin, dopamine, and norepinephrine available for the brain to use. This is a very similar mechanism to many modern Shri antidepressants. A landmark 2008 Cochrane review, a gold standard in evidence-based medicine, analyzed 29 trials with over 5,000 patients. It concluded that St. John's wort was more effective than a placebo and worked as well as standard antidepressants, but with fewer side effects for major depression. The medieval link between nerve pain and mood is also fascinating. They used the red oil for wounds and what they called nerve damage. Today, research is exploring its potential for treating neuropathic pain. It seems the same plant that balances brain chemistry might also help repair physical nerve pathways. They saw a connection between the mind and the body that we are only now reappreciating. But honesty is important here. St. John's wort is not a simple, harmless flower. It has a dark side. It interacts with a huge number of prescription medications. It can make birth control pills less effective. It can interfere with blood thinners, heart medications, and even life-saving HIV drugs. It's a powerful herb that demands respect. So, were they driving out demons, or were they rebalancing brain chemistry? The language is different, but the goal was the same: to lift a heavy, dark cloud from the human spirit. But what do we still not understand? How does a plant evolve to create a complex molecule that fits so perfectly into human brain receptors? If standardized extracts focus only on hyperforin, are we missing the benefits of the hundreds of other compounds in the plant? And could the medieval belief in its protective spiritual power have created a placebo effect that worked in tandem with the herb's actual chemistry? Number 15, could a foul-smelling root really bring you peace? Sleep has always been a precious commodity, and for those in medieval times, a sleepless night wasn't just tiring. It was filled with anxieties we can barely imagine. Without the buffer of modern society, a sleepless mind could easily turn to worries of famine, plague, or war. To find peace, they turned to a plant with a notoriously unpeaceful smell. Valerian, like the root of the valerian plant, has a pungent, earthy, and frankly unpleasant odor, often compared to old socks. But its reputation was golden. The name itself is thought to come from the Latin word valere, meaning to be strong or to be well. It was the go-to remedy for hysteria, nervousness, anxiety, and, most famously, insomnia. The great Greek physician Galen, whose teachings dominated medieval medicine for over 1,000 years, recommended it as a sleep aid in the 2nd century. By the medieval period, it was a staple in monastic and household gardens. They believed it calmed the nerves and quieted a troubled mind, allowing for a restful sleep without the heavy, drugged feeling of other sedatives like opium. The modern science has taken a deep, and sometimes confusing, look into the smelly root. Unlike willow or St. John's wort, there isn't one single magic bullet compound. Instead, valerian seems to work through a symphony of different chemicals. The most studied are valerianic acid and various iridoids called valipotriates. The leading theory is that these compounds interact with the brain's GABA-gamma aminobutyric acid system. GABA is the brain's primary inhibitory neurotransmitter. Its job is to calm things down, to reduce neuronal excitability. Think of it as the brain's off switch. Valerianic acid seems to prevent the breakdown of GABA, meaning more of it is available to quiet the brain. This is a similar, though milder, mechanism to drugs like Valium and Xanax. The research can be a bit mixed, partly because the quality and composition of valerian extracts can vary so much. However, many studies do support its traditional use. A 2006 meta-analysis from the American Journal of Medicine looked at 16 different studies with over 1,000 patients. The conclusion was that valerian might improve sleep quality without producing the hangover effects common with prescription sleeping pills. It doesn't seem to force you to sleep. Instead, it seems to reduce the time it takes to fall asleep and improve the overall quality of that sleep. It's a gentle nudge, not a sledgehammer. This perfectly matches the medieval description of it as a calmer of nerves, not a stupefying drug. They didn't have the language of GABA receptors. They just knew that a tea made from a stinky root could help an anxious person find their way to a quiet night's rest. But what are the real mysteries here? Since there's no single active compound, how do the dozens of chemicals in valerian root work together? Is it possible that the unpleasant smell itself, through some primal olfactory pathway, plays a role in its calming effect? And if it works on the same brain system as benzodiazepines, could we learn something from this plant about creating safer, less addictive anti-anxiety medications? Number 14, can a spice for cookies also soothe a sick stomach? Long journeys in the medieval world were brutal. Whether by sea or by land, the food was often spoiled, the water questionable, and the motion relentless. Nausea and stomach upset were a constant threat. Sailors, pilgrims, and merchants all needed something to settle their churning stomachs. One of their most prized remedies was not a local weed, but an exotic, expensive spice from the East, ginger. Ginger was known in Europe long before the Middle Ages, brought from Asia via the spice routes. It was incredibly valuable, a luxury item, but it was also considered a powerful medicine. It was a hot and dry plant in the system of humoral medicine, perfect for counteracting cold and damp stomach ailments. It was used for indigestion, gas, and most notably nausea. It was so effective that it became a key ingredient in many culinary dishes, not just for flavor, but to aid in the digestion of heavy medieval meals. The word gingerbread itself has medieval origins, evolving from a term for preserved ginger. They were essentially embedding their medicine directly into their food. Today, ginger is one of the most well-validated herbal remedies on the planet. Its anti-nausea effects are not just folklore, they're a well-documented scientific fact. The primary active compounds are called gingerols and shogals. These are the pungent, spicy chemicals that give ginger its kick. They work in several ways. They seem to speed up gastric emptying, moving food out of the stomach more quickly so it has less time to cause problems. They also appear to work directly on the brain and nervous system, blocking serotonin receptors in both the gut and the brain's vomiting center. The scientific evidence is extensive. A 2014 review published in the journal Nutrition looked at multiple studies and found ginger to be an effective and inexpensive treatment for nausea and vomiting with few side effects. It's now commonly recommended for many types of nausea. It's used for motion sickness, which plagued those medieval travelers. It's used for morning sickness in pregnancy, a recommendation that echoes its historical use for women's health. And it's even used to combat the intense nausea experienced by patients undergoing chemotherapy. A major 2012 study funded by the National Cancer Institute found that ginger supplements significantly reduced nausea in cancer patients. They didn't know about gingerols or serotonin receptors. They didn't know the precise mechanisms of the digestive tract. They just knew that chewing on a piece of this spicy root or drinking it in a tea could calm a roiling sea both on the ocean and inside their own bodies. They paid a high price for it, but for a traveler far from home, a settled stomach was worth its weight in gold. But big questions remain. We know it works, but do the different compounds in ginger, the gingerols and shogals, target different types of nausea? How does the plant's effect on the gut's microbiome, the trillions of bacteria living inside us, contribute to its overall health benefits? And is it possible that other, less studied compounds in the ginger root are responsible for some of its other traditional uses, like pain relief and reducing inflammation? Number 13, why was this pungent bulb? Warned to ward off the plague. The Black Death was a terror unlike any other. It swept through Europe in the mid-14th century, killing an estimated 1/3 of the population. With no concept of germs or viruses, people were desperate. They turned to prayer, to magic, and to any plant that had a reputation for power and protection. At the top of that list was a common, pungent bulb garlic. Garlic's reputation was ancient. The Egyptians fed it to the slaves building the pyramids to keep them strong. Greek soldiers ate it for courage, but in medieval Europe, it became a talisman against pestilence. Plague doctors, with their beaked masks, would stuff the beaks with aromatic herbs, and garlic was almost always among them. People wore cloves of it around their necks. They hung it in their homes. They ate it in massive quantities, hoping its powerful heat and smell would drive away the miasma, the bad air they believed caused the disease. It was the poor man's theriac, a cure-all for the common folk. This association with warding off evil and disease is so strong it even bled into folklore, becoming the classic weapon against vampires. Was it all just superstition, a desperate hope in the smelly bulb? Not entirely. We now know that the plague was caused by the bacterium Yersinia pestis, and garlic is in fact a potent natural antibiotic. Its power comes from a compound called allicin. Interestingly, allicin doesn't exist in a whole garlic clove. When the clove is crushed or cut, an enzyme called alliinase rapidly converts a precursor molecule, alliin, into the sulfur-rich allicin. This is the compound responsible for garlic's characteristic odor and its powerful medicinal properties. Allicin is a defense mechanism for the plant, designed to ward off pests and pathogens. Modern science has confirmed garlic's broad-spectrum antimicrobial activity. Countless laboratory studies have shown that garlic extracts can inhibit the growth of, or even kill, a huge range of bacteria, viruses, fungi, and parasites. A 2014 study in the Journal of Applied Microbiology noted its effectiveness against foodborne pathogens like Salmonella and E. coli. While it's unlikely that wearing a necklace of garlic could stop you from being bitten by a plague-infected flea, consuming large amounts of it might have bolstered the immune system. The sulfur compounds in garlic are known to enhance the function of immune cells. Beyond its antimicrobial effects, garlic is now extensively studied for its cardiovascular benefits. As research has shown, it can modestly lower blood pressure, reduce cholesterol, and inhibit blood clot formation. The famous medieval abbess and healer, Hildegard of Bingen, recommended garlic, but only in moderation, recognizing its potent nature. She was right. While incredibly beneficial, it can also act as a blood thinner, and people on anticoagulant drugs need to be cautious. They thought they were fighting bad air and evil spirits. In reality, they were deploying a powerful antibacterial and immune-boosting agent. The form of the enemy was misunderstood, but the choice of weapon was surprisingly astute. But what do we still need to figure out? Allicin is a very unstable compound and breaks down quickly. How much of it actually gets absorbed and used by the body when we eat garlic? Are there other, more stable sulfur compounds in garlic that are just as important for its health effects? And could the genetic modification of garlic to produce even higher levels of these compounds create a new generation of natural antibiotics to fight resistant bacteria? Number 12. Did they use a pretty flower as a sedative and an antiseptic? The color purple has long been associated with royalty and calm, and in the medieval herb garden, one purple flower stood out for its incredible fragrance and its soothing reputation, lavender. Its name comes from the Latin lavare, to wash, because the Romans used it to scent their baths. In the Middle Ages, this washing went beyond the physical. It was used to wash away worries. Monks and herbalists grew lavender for its calming properties. It was strewn on the floors of castles and sick rooms, not just to perfume the air and cover up unpleasant smells, but with the belief that its scent could purify the air and prevent disease. Hildegard of Bingen recommended it for maintaining a pure character. It was used in teas and pillows to help with sleep and ease anxiety. During plague outbreaks, it was one of the key ingredients in Four Thieves vinegar, a concoction believed to protect grave robbers from catching the disease. Glove makers in Grasse, France, who scented their leather with lavender, were noted to have a lower incidence of cholera. It was seen as both a sedative and a shield. Modern science has found that these uses are remarkably on target. The primary active constituents in lavender's essential oil are linalool and linalool acetate. When inhaled, these molecules travel from the olfactory nerves directly to the brain, where they appear to work on the limbic system, particularly the amygdala, the brain's emotional center. Like valerian, lavender also seems to interact with the GABA neurotransmitter system, calming nervous system activity. A 2017 study published in the journal Frontiers in Behavioral Neuroscience used animal models to show that inhaling linalool had an anxiolytic or anti-anxiety effect comparable to diazepam Valium, but without the same motor-impairing side effects. Its use as a sleep aid is also well supported. Numerous studies have shown that the scent of lavender in a bedroom can improve sleep quality, increase the duration of deep, slow-wave sleep, and help people wake up feeling more refreshed. It doesn't act like a sleeping pill, but rather seems to reduce the anxiety and racing thoughts that often prevent sleep. And what about its use as a shield against disease? That wasn't just wishful thinking either. The essential oil of lavender has proven antimicrobial properties. A 2011 study from the Society for General Microbiology showed that lavender oil was lethal to a range of skin pathogenic fungi. Other research has shown it has antibacterial and antiviral effects. While it wouldn't stop the plague, its use in sick rooms and on wounds was a very sensible, if basic, form of antiseptic practice. It was a medieval bottle of Lysol, but one that also calmed you down. They believed its beautiful scent could purify the soul and the air. We now know that its aromatic molecules can calm the brain and kill microbes. Two different explanations for the same observable results. But what are the lingering puzzles? How does the scent of lavender affect our hormonal systems like cortisol, the stress hormone? Could specific combinations of lavender's many chemical compounds be more effective for anxiety versus sleep versus antimicrobial uses? And is it possible that our modern deodorized world has made us less sensitive to the powerful psychological and physiological effects that aromas had on our ancestors? Number 11. Could a common garden weed relieve a headache? Headaches are a universal human affliction. In the Middle Ages, they were often attributed to an imbalance of the humors, particularly an excess of choler or heat in the head. To cool things down, they reached for a plant that is now a familiar flavor in chewing gum and toothpaste, peppermint. A member of the mint family, peppermint was cultivated in monastery gardens across Europe. The 9th century monk Walfrid Strabo wrote about it extensively in his garden poem, Hortulus, praising its many virtues. It was a primary remedy for all manner of digestive complaints, from indigestion to cramps, which is a use that continues to this day. But it was also widely applied for headaches. They would crush the fresh leaves and apply them as a poultice directly to the temples. The cooling, tingling sensation was believed to draw the excess heat out of the head, providing relief. This is not a magical belief. It's a direct physical sensation that has a real physiological basis. The main active compound in peppermint is menthol. When applied to the skin, menthol activates a specific receptor called TRPM8. This is the same receptor that our sensory nerves use to detect cold temperatures. So, when you put peppermint oil on your skin, you are essentially tricking your nerves into thinking they're feeling cold, even though the temperature hasn't changed. This creates the familiar cooling sensation, which can be a powerful distraction from pain. But it does more than just create a distraction. Menthol is also a vasodilator, meaning it helps to relax and widen blood vessels. Many tension headaches are thought to be caused or exacerbated by constricted blood vessels. A famous 1996 study conducted at the University of Kiel in Germany tested the effects of a 10% peppermint oil solution applied to the foreheads and temples of patients with tension headaches. They found it was as effective as taking 1,000 milligrams of acetaminophen Tylenol, but without the potential side effects on the liver. The menthol appears to both relax the muscles in the forehead and improve blood flow, tackling the headache from two different angles. Its use for stomach problems is also rock solid. Menthol has an antispasmodic effect on the smooth muscle of the digestive tract. It helps to relax the gut, allowing trapped gas to pass and relieving the painful cramps associated with conditions like irritable bowel syndrome (IBS). Enteric-coated peppermint oil capsules, which survive the stomach acid to release their contents in the intestines, are now a common mainstream recommendation for IBS. They thought they were cooling an overheated humor. We know we are activating a cold-sensing nerve receptor and relaxing smooth muscle tissue. The explanation has evolved, but the simple act of applying mint to the skin for a headache remains a surprisingly effective remedy. But what don't we get? How exactly does menthol's effect on blood vessels translate into pain relief for something as complex as a headache? Could different types of mint with slightly different chemical profiles be better suited for different types of pain or digestive issues? And what is the full extent of peppermint's effect on the gut-brain axis, the complex communication network that links our digestive health directly to our mental state? Number 10 is, there a reason we say rosemary for remembrance. Memory is fragile. It connects us to our past and helps us navigate our future. For medieval scholars, students, and the elderly, preserving and enhancing memory was a serious concern. And for this, they had a specific herb, rosemary. The association between rosemary and memory is ancient. Failure. In Shakespeare's Hamlet, famously says, "There's rosemary, that's for remembrance." But Shakespeare was tapping into a belief that was already centuries old. In medieval Europe, students would braid rosemary into their hair or simply smell it before an exam. It was placed in the hands of the dead to signify that they would not be forgotten. It was a symbol of fidelity and a tool for the mind. They believed its pungent, invigorating scent could sharpen the senses and awaken the memory. For centuries, this was dismissed as poetic folklore, but recent scientific investigation suggests there is a real chemical basis for this age-old tradition. The key may lie in a compound called 1,8-cineol, one of the main aromatic components of rosemary oil. This compound can be absorbed into the bloodstream simply through inhalation. From there, it can cross the blood-brain barrier. A fascinating 2012 study by Mark Moss and his team at Northumbria University in the UK explored this connection. They exposed participants to varying levels of rosemary aroma while they performed cognitive tasks. They also took blood samples to measure the levels of 1,8-cineol. The results were striking. The higher the concentration of 1,18-cineol in the blood, the better the participants performed on speed and accuracy tests. It seemed to directly improve cognitive performance. Further research suggests how it might work. Compounds in rosemary, including carnosic acid, appear to inhibit the breakdown of acetylcholine, a key neurotransmitter for memory and learning. This is the same mechanism of action used by some modern drugs for treating Alzheimer's disease. Rosemary's benefits might not stop at memory. It's a potent antioxidant and anti-inflammatory, properties that are crucial for overall brain health. By protecting the brain from oxidative stress and inflammation, it may help to preserve cognitive function over the long term. So when a medieval student breathed in the scent of rosemary, they weren't just engaging in a ritual. They were likely absorbing a chemical that was actively improving their brain's ability to process and recall information. They were practicing a form of aromatherapy that science is only now beginning to validate. But what are the next frontiers? Does the method matter? Is inhaling the scent different from drinking it as a tea or eating it in food? Could specific compounds from rosemary be isolated to create new, more effective treatments for dementia and age-related cognitive decline? And how does the simple act of associating a particular scent with the act of remembering create a powerful psychological trigger that works alongside the herb's chemistry? Number 9. Why did they put this common kitchen herb in their shoes? A sore throat in the Middle Ages could be a minor annoyance or the first sign of a deadly illness. With no antibiotics, even a simple infection could turn serious. One of the most common remedies used both as a medicine and a food preservative was sage. The name sage comes from the Latin salvere, meaning to save or to be healthy. It held a place of honor in the medieval garden. There was an old saying, "Why should a man die while sage grows in his garden?" It was the first line of defense against coughs, colds, and especially sore throats. They would make a strong tea from the leaves and use it as a gargle. They also believed it could enhance memory, a property often linked with its cousin rosemary. A lesser known but fascinating use was to place sage leaves in shoes to soothe tired, aching feet. The use of sage as a throat gargle is scientifically sound. Sage contains a potent mix of active compounds including camphor, borneol, and especially thujoni. These chemicals have strong antiseptic, antibacterial, and astringent properties. When you gargle with sage tea, you are washing the infected tissues with a natural disinfectant. The astringent quality helps to tighten and soothe the swollen, irritated membranes of the throat, providing immediate relief from pain. A 2009 study published in the European Journal of Medical Research tested a sage and echinacea spray on patients with acute sore throats. It was found to be just as effective as a conventional spray containing the chemical antiseptic chlorhexidine and the painkiller lidocaine. Its memory-enhancing reputation is also being investigated. Like rosemary, sage appears to inhibit the enzyme that breaks down the neurotransmitter acetylcholine. A 2003 study, also from the Human Cognitive Neuroscience Unit at Northumbria University, showed that young adults who took sage oil capsules had significantly improved word recall. And what about the tired feet? It seems odd, but it makes sense. The same antiseptic properties that worked on a sore throat would have helped to combat the bacteria and fungi that cause foot odor. And its anti-inflammatory properties could have helped to soothe the aches and pains from a long day of walking on rough medieval roads. But there's a caution. The compound thujoni, while medicinally active, can be toxic in high doses. This is why sage is used as a culinary herb in small amounts, and why highly concentrated sage oils should be used with care. The medieval herbalists, using the whole leaf in a simple water infusion, were using a method that was both effective and safe. They believed it was a savior herb. We know it is a potent cocktail of antibacterial and anti-inflammatory compounds. The result is the same as soothing remedy for a raw, painful throat, but questions persist. There are hundreds of species of sage. Do they all share the same medicinal properties, or are some better for the throat and others better for the brain? How does the thujoni content vary based on where the plant is grown and when it is harvested? And could we discover other compounds in sage that explain its vast range of traditional uses, from stemming bleeding to promoting digestion? And number 8 was this tiny leaved herb, really a source of courage. Well, courage was a vital virtue in the harsh medieval world for knights on the battlefield and for ordinary people facing sickness and hardship. And when they needed a boost of bravery, they sometimes turned to a small, humble herb thyme. The word thyme is thought to derive from the Greek word thumos, meaning courage. Roman soldiers bathed in water infused with thyme to gain vigor before a battle. In the Middle Ages, ladies would often embroider a sprig of thyme on the scarves they gave to their knights as a token of courage. It was also placed under pillows to ward off nightmares and promote a peaceful, brave sleep. Beyond courage, it was a primary medicine for respiratory ailments. A cough, especially the deep, racking cough of what we now call bronchitis, was treated with syrups and teas made from thyme. The link to courage might seem purely symbolic, but its use for coughs was absolutely practical. The major active component in thyme is a phenol called thymol. Thymol is a remarkably powerful antiseptic and antimicrobial. In fact, before the advent of modern antibiotics, thymol was one of the main ingredients in Listerine mouthwash, and it's still used today in some antiseptic products for its ability to kill germs. When you drink thyme tea, the thymol helps to fight the bacteria or virus causing the respiratory infection. But thymol does more. It is also a powerful expectorant and antispasmodic. An expectorant helps to thin and loosen mucus in the airways, making it easier to cough up and clear the lungs. An antispasmodic helps to relax the muscles of the trachea and bronchi, calming the spasms that create a cough. This dual action is what makes thyme so effective. It doesn't just suppress the cough, it makes the cough more productive and less severe. Modern Germany's Commission E has officially approved thyme for treating the symptoms of bronchitis, whooping cough, and upper respiratory inflammation. And its antiseptic nature explains another of its medieval uses. It was a key ingredient in poultices and washes for cleaning wounds on the battlefield. A dressing soaked in thyme infusion was a primitive but effective way to prevent infection. It was a soldier's medicine in every sense. So while it may not have magically instilled courage, a knight going into battle free from a hacking cough and with his wounds less likely to fester would certainly have been a more effective and confident fighter. The courage it gave was the courage of good health. But what are the remaining unknowns? Thymol is potent, but are there other compounds in thyme that work with it to soothe the lungs? How does thyme affect the lungs microbiome, the community of bacteria living in our airways? And could a better understanding of its antispasmodic properties lead to new treatments for other conditions involving muscle spasms like asthma? Number 7. Could a common weed actually stop bleeding? Wounds were a fact of life in medieval times. A slip of a knife in the kitchen, a fall in the field, or the slice of a sword in battle could all lead to dangerous bleeding. Without knowledge of sterile procedure or advanced surgery, stopping the flow of blood was the most critical first step. For this, they had a plant they called soldier's woundwort, or Herba militaris. We know it today as yarrow. The plant's botanical name, Achillea millefolium, ties it directly to the legend of Achilles, the great Greek warrior. The story goes that he used yarrow to treat the wounds of his soldiers during the Trojan War. This reputation carried straight through to the Middle Ages. It was an essential battlefield herb. Soldiers would carry it with them dried and powdered to stuff into wounds to stop bleeding. Its feathery leaves, which look like they are made of 1,000 tiny leaflets millefolium means, 1,000 leaf, were crushed and applied directly to cuts. This wasn't just a folktale. Yarrow works. The plant contains several compounds that contribute to its wound healing abilities. First, it contains alkaloids, including one named acalini, which is believed to have hemostatic properties, meaning it helps to stop bleeding by encouraging blood coagulation. It acts as a styptic, constricting the blood vessels and helping a clot to form more quickly. Second, yarrow has powerful anti-inflammatory and antiseptic properties. It contains flavonoids and sesquiterpene lactones, which reduce swelling and fight off bacteria. So when a medieval soldier packed yarrow into a wound, they weren't just plugging the hole. They were applying a complex natural medicine that stopped the bleeding, reduced inflammation, and helped prevent a deadly infection from setting in. It was a battlefield first aid kit in a single plant. Modern science is catching up. A 2017 study on animal models published in the Journal of Ethnopharmacology found that a yarrow extract significantly accelerated wound healing, promoting tissue regeneration and collagen synthesis. Other lab studies have confirmed its antibacterial action against common culprits like Staphylococcus aureus. They saw it stop bleeding and called it soldier's wound wort. We see it contains acrolein and flavonoids that promote hemostasis and fight bacteria. The name has changed, but the plant's function has not. It's a vivid reminder that effective medicine doesn't always come from a lab. Sometimes it comes from the weeds growing by the side of the road, but what do we not know for sure? How exactly does the alkaloid acrolein interact with our blood's clotting factors? Could different preparations of yarrow, a fresh leaf poultice versus a dried powder versus a water extract have dramatically different effects on a wound? And are there other, yet to be identified compounds in this common weed that could be developed into new, advanced wound healing treatments? Number 6 was a berry on a thorny bush, a secret to a strong heart. In medieval medicine, the heart was more than just a pump. It was the seat of courage, love, and the vital spirit. A weak heart could mean sadness and despair as much as it could mean physical frailty. To strengthen the heart, both physically and spiritually, they often turned to the thorny hawthorn bush. Hawthorn was a plant of boundaries and borders, often used for hedges. It was also steeped in folklore associated with fairies and the supernatural. But healers knew it as a cordial, a tonic for the heart. They used the bright red berries, the leaves, and the flowers to make tonics and wines for elderly people with shortness of breath, fatigue, or what they might have described as a failing vital force. It wasn't for a sudden heart attack, but a gentle, long-term support for an aging heart. This is one of the most remarkable examples of a traditional use being confirmed by modern cardiology. Hawthorn is now a widely respected and researched herbal treatment for the early stages of congestive heart failure. It is a mainstream prescription medicine in countries like Germany and Switzerland for this exact condition. The plant works in a multi-targeted way. It is rich in a group of powerful antioxidant compounds called flavonoids and oligomeric procyanidins OPCs. These compounds seem to improve the heart's function in several ways. First, they are thought to increase the force of the heart's contraction, allowing it to pump blood more efficiently without requiring more oxygen. This is known as a positive inotropic effect. Second, they act as vasodilators, relaxing and opening up the blood vessels, particularly the coronary arteries that supply blood to the heart muscle itself. This lowers blood pressure and reduces the workload on the heart. A major Cochrane review in 2008 analyzed 14 randomized controlled trials. The researchers concluded that for patients with chronic heart failure, hawthorn extract, when used alongside conventional treatment, was significantly better than a placebo at improving exercise tolerance and reducing symptoms like shortness of breath and fatigue. It appeared to be a safe and effective support for a struggling heart. The medieval healers described it as a tonic or a cordial. They observed that it gently helped people with weak hearts feel stronger over time. Modern science has revealed the precise mechanisms, improved contractility, and vasodilation. The language is more clinical now, but the outcome they were aiming for, a stronger, more efficient heart wort, was exactly right. But the most profound questions are still unanswered. How does the complex mixture of dozens of compounds in hawthorn achieve a balanced effect that isolated drugs often struggle to match? Could long-term use of hawthorn from a younger age actually help prevent the development of heart disease later in life? And what else can this plant teach us about treating complex, chronic conditions with gentle, multi-targeted natural therapies instead of single molecule silver bullets? Number 5, could a pea in your lawn actually be a medicine? To most of us, it is a persistent weed, the bane of a perfect green lawn. But in the medieval world, the dandelion was not a pest. It was a respected medicine and a valuable food source. Every part of the plant was used, from the flower to the root. But its most famous medicinal use was for what they called obstructions of the liver and kidneys. The common name for dandelion in French is pissenlit, which literally translates to piss in bed. This points directly to its best-known property. It is a powerful diuretic, and medieval herbalists used it to increase the flow of urine, believing this would help to cleanse the body of toxins and relieve conditions like fluid retention or edema. They also saw it as a liver tonic, something that could help a sluggish liver function better. The famous 17th century herbalist Nicholas Culpeper wrote that it openeth the passages of the urine and cleanseth the blood. Modern science has shown that these old herbalists were spot on. Dandelion is indeed an effective diuretic. A 2009 pilot study at the Thai Sophia Institute in Maryland had volunteers consume a dandelion leaf extract. The results showed a significant increase in the frequency of urination in the 5 hours after consumption. What makes dandelion particularly interesting as a diuretic is that it is also incredibly rich in potassium. Many pharmaceutical diuretics work by flushing out sodium, but they often take potassium along with it, which can lead to dangerously low levels of this vital mineral. A dandelion, on the other hand, provides a fresh supply of potassium, making it a naturally potassium-sparing diuretic. And its reputation as a liver tonic is also being borne out by research. The bitter compounds in the root are thought to stimulate bile production and flow from the liver and gallbladder. This bile is crucial for digesting fats and for carrying waste products out of the body. By improving bile flow, dandelion may indeed help the liver perform its detoxifying duties more efficiently. Animal studies, such as one published in the Journal of Ethnopharmacology in 2010, have shown that dandelion root extract can have a protective effect on the liver against damage from toxins. They saw a plant that made you urinate more and called it piss abed. They used it to cleanse the system. We see a potassium-sparing diuretic that stimulates bile flow. The framing is different, but the application is identical. The medicine was hiding in plain sight, dismissed as a common weed, but what are the truly deep questions here? How does the dandelion's diuretic mechanism differ from pharmaceutical drugs at the cellular level? Could compounds from dandelion root be developed into a new class of liver protective drugs? And how much have we lost by systematically removing this and other weeds from our modern sanitized food supply, plants that our ancestors ate as a matter of course? Number 4, why would anyone intentionally sting themselves with a painful plant? The stinging nettle is a plant most of us learn to avoid from a young age. Its leaves and stem are covered in tiny, hollow hairs that act like hypodermic needles, injecting a cocktail of irritating chemicals like formic acid and histamine when touched. It causes an immediate, painful, itchy rash. So why on earth would medieval healers use this plant as a medicine, especially for the very thing it seems to cause pain and inflammation? In one of the most counterintuitive practices in herbal medicine, they used it to treat arthritis. The practice was called urtication, from the nettle's Latin name urtica. It involved intentionally flogging the painful arthritic joints with fresh nettle stalks. The idea was that the intense acute sting from the nettle would somehow overwhelm or replace the chronic deep ache of the arthritis. It was a classic example of fighting fire with fire. Nettle was also consumed as a food and a tea, believed to be by legend by blood purifier and a remedy for the dampness associated with aching joints. It sounds like madness, but there's a fascinating scientific theory behind it. When the nettle stings you, it injects histamine and other inflammatory chemicals. This causes a powerful, localized inflammatory response. In response to this sudden assault, the body's own anti-inflammatory system kicks into high gear. It's like sounding a 5-alarm fire bell that brings out all the emergency crews. These crews then not only deal with the nettle sting, but may also go to work on the underlying chronic inflammation of the nearby arthritic joint. Furthermore, the constant stimulation of the pain nerves might deplete the supply of substance P, a neurotransmitter that signals pain to the brain, leading to long-term relief. A 1999 randomized controlled trial at the Peninsula Medical School in the UK looked at this very practice. Patients with arthritic thumb pain applied either stinging nettle or a placebo leaf daily for a week. The results showed that the nettle application led to a significant reduction in pain and disability compared to the placebo. It's a strange idea, but it appears to work. Even without the stinging, nettle is a powerful anti-inflammatory. When cooked or dried, the sting is neutralized. Consumed as a food or tea, nettle is a nutritional powerhouse, packed with vitamins and minerals, and it contains compounds that appear to inhibit the production of inflammatory cytokines in the body. So eating nettle soup, a common medieval dish, was likely another way they were treating their joint pain. They saw a plant that caused a sting and thought they could use that sting to fight a deeper pain. We see a plant that triggers a complex cascade of anti-inflammatory responses and depletes pain neurotransmitters. The method is bizarre, but the result is relief. But what do we still find puzzling? What is the full list of chemicals in a nettle sting, and how do they interact with our nervous system? Could we isolate the compounds that are beneficial for arthritis without the painful sting? And how did our ancestors' different relationship with pain allow them to embrace a remedy that seems so torturous to us today? Number 3, could a sweet, gummy root be the secret to soothing a cough? Coughs and sore throats were a constant winter misery in the drafty, damp buildings of the Middle Ages. Without modern cough suppressants, they needed something to coat and soothe the raw, irritated tissues of the throat and lungs. For this, they often turned to a plant that grew in marshes and wet meadows, the marshmallow plant. This isn't the fluffy white confection you toast over a fire. This is the original marshmallow, Althea officinalis. The root of this plant is rich in a slimy, gummy substance called mucilage. When the root is soaked in water, it releases this mucilage, creating a thick, soothing liquid. Medieval healers would make syrups and teas from the marshmallow root to treat dry, hacking coughs, sore throats, and even stomach inflammation. They recognized its ability to provide a protective coating over irritated mucous membranes. The effect was immediate and physical. The science here is wonderfully straightforward. The mucilage is made of large polysaccharide molecules that, when mixed with water, swell up and form a gel-like layer. When you drink marshmallow root tea, this gel physically coats the lining of your throat, mouth, and esophagus. This has several benefits. It acts as a barrier, protecting the irritated nerve endings from further aggravation, which helps to calm the cough reflex. It soothes the inflammation directly, and it has a moisturizing effect on dry tissues. This property is known as a demulcent effect. Modern medicine still uses demulcents, often in synthetic forms, in throat lozenges and cough syrups. Marshmallow root is simply the original plant-based version. Germany's Commission E has approved the use of marshmallow root and leaf for irritation of the mouth and throat and the associated dry cough. Its soothing properties are so effective that it is also used for inflammatory stomach conditions like gastritis and ulcers, where it can provide a protective coating for the stomach lining. They didn't have the word polysaccharide or demulcent. They just knew that the slimy stuff from this particular root made their sore throat feel better. It's a perfect example of medicine based on direct, tangible, physical properties that anyone could see and feel. The original marshmallows made in the 19th century actually used the mucilage from the plant's root as their gelling agent, a direct link back to its medicinal origins. But what are the unanswered questions? How does the mucilage from marshmallow root interact with the microbiome of our throat and gut? Are there other non-mucilage compounds in the root that contribute to its healing properties, perhaps by actively reducing inflammation? And could this plant's unique coating ability be used in novel ways, perhaps to help with the delivery of other medicines to specific parts of the digestive tract? Number 2 was a golden flower, the key to healing damaged skin. In a time before antiseptic wipes and antibiotic creams, any break in the skin was a potential entry point for a deadly infection. Wounds, burns, rashes, and insect bites all needed to be treated carefully. One of the most beloved and widely used skin healing herbs was a cheerful golden flower that bloomed for months on end calendula, also known as pot marigold. Calendula was a fixture in both the medicine garden and the kitchen. Its petals were used to color cheese and butter and were added to soups and stews, earning it the name poor man's saffron. But its real value was in healing the skin. Herbalists would make oils, salves, and ointments from the flower heads. These were applied to any and all skin problems, minor wounds, burns, sunburns, eczema, and even varicose veins. They believed it could speed healing, prevent putrefaction, infection, and reduce scarring. Hildegard of Bingen recommended it for skin irritations. The science behind calendula's skin healing prowess is robust. The bright orange and yellow petals are packed with a high concentration of antioxidant compounds, especially flavonoids and carotenoids like lycopene and lutein. These antioxidants help to protect the skin cells from damage caused by free radicals. But that's just the start. Calendula appears to work on multiple fronts. First, it is a potent anti-inflammatory. Compounds called triterpenoids in the flowers help to reduce swelling, redness, and pain. Second, it has antimicrobial properties, showing activity against various bacteria and fungi that can infect skin wounds. This validates the medieval belief that it prevented putrefaction. Third, and perhaps most importantly, it seems to actively promote healing. Your studies suggest that calendula extracts can increase blood flow to the wounded area and stimulate the production of collagen, the primary protein that makes up our skin. This process, called granulation, is essential for rebuilding healthy tissue and closing a wound. A 2016 study in the Journal of Wound Care found that women who used a calendula ointment after a C-section had faster healing times with less redness and swelling compared to those receiving standard hospital treatment. They saw that a golden flower, when made into a salve, helped skin heal faster and cleaner. We see a complex array of flavonoids, triterpenoids, and carotenoids that reduce inflammation, fight microbes, and promote collagen synthesis. It's a beautiful intersection of ancient observation and modern molecular biology. But what do we still need to learn? Which specific compound in calendula is most responsible for stimulating collagen production? Could an extract of this flower be used to create better treatments for chronic wounds like diabetic ulcers? And how does the method of extraction, an oil infusion versus an alcohol tincture, for example, change the chemical profile and the ultimate healing power of the final remedy? Number one, did they really know how to heal bones with a plant? Broken bones were a catastrophic injury in the Middle Ages. Setting a bone was a crude and painful process, and ensuring it healed properly without infection or deformity was a huge challenge. For this most difficult of tasks, they had a special plant, a plant whose very name speaks to its purpose. They called it comfrey, and another of its common names was knitbone. Comfrey was the orthopedic specialist of the medieval herb garden. Herbalists would make a poultice from its large, hairy leaves and thick, black root. This slimy green paste would be plastered around the site of a fracture, then bound tightly in place. The belief was that the plant would literally help to knit the broken ends of the bone back together. It was also used for any kind of deep tissue injury, sprains, strains, bruises, and torn ligaments. It was considered so powerful that it was almost exclusively used externally. There was an understanding even then that it was too potent to be taken internally in large amounts. This ancient reputation is now backed by some startling modern science. Comfrey contains two key compounds that explain its remarkable healing ability. The first is allantoin. Allantoin is a substance that promotes cell proliferation. It speeds up the growth of new cells, which is exactly what you need to repair damaged tissue, whether it's skin, muscle, or bone. The body naturally produces some allantoin, but comfrey provides a huge external dose right where it's needed. In fact, allantoin is so effective that it is now synthesized and used in many modern pharmaceutical creams for wound healing. The second key compound is rosmarinic acid. This substance has powerful anti-inflammatory and analgesic pain-relieving properties. So when a comfrey poultice was applied, it wasn't just speeding up cell growth with allantoin, it was also reducing the swelling and pain with rosmarinic acid. It was a complete treatment, a pain reliever, an anti-inflammatory, and a growth stimulant, all in one plant. Numerous modern clinical trials have confirmed its effectiveness. A 2013 review published in the journal Phytotherapy Research looked at multiple studies on comfrey for pain and inflammation. It concluded that comfrey preparation showed remarkable efficacy and a very positive safety profile when used topically for muscle and joint pain. Studies on ankle sprains and back pain have shown comfrey creams to be significantly more effective than a placebo. But the medieval caution about using it internally was also profoundly wise. We now know that comfrey contains pyrrolizidine alkaloids, compounds that can be toxic to the liver if ingested in significant quantities. This is why the sale of comfrey for internal use is now restricted in many countries. The medieval herbalists, through generations of observation, had figured out the plant's great power and its hidden danger, establishing a safety protocol that science would only confirm centuries later. They called it knitbone because they saw it heal broken bones. We now know it contains allantoin, a cell proliferant, and rosmarinic acid, an anti-inflammatory. They saw a miracle, we see a mechanism, but the result, amended bone, is the same. It stands as perhaps the most dramatic example of a medieval remedy that is not just relevant, but scientifically and astonishingly correct. But what is the final, deepest mystery? How does the allantoin from a topical poultice actually penetrate the skin and tissues to reach a broken bone deep inside the body? Other undiscovered compounds in comfrey that enhance the delivery or action of allantoin and rosmarinic acid. And could we learn from comfrey's unique chemistry to create a new generation of medicines that don't just manage injuries, but actively and rapidly accelerate the body's own power to heal?